Hello everyone, welcome to Data Avenue. In this video, I'm going to talk about flattened semi-structured data. I'm taking a Spark Scala as an example. So usually, either structured or semi-structured data, we use data frame to read the data. If it's a structured data, so let's say there is a table called A from database, what we do is we create a SQL, select star from db dot the table name, read the whole stuff into data frame, and then apply the transformations. Similarly, the same manner we would be using it for reading the semi-structured data as well. So what are the semi-structured data? XML or JSON kind of files as the semi-structured data. So here I'm going to talk about the JSON file as an example. So if you look at this, the sample file, it's a very straightforward. We have a name, age, email, and city. So once you read this file into data frame and look at the schema, so what you see it on the right side, the schema, it's a very straightforward. Name, age, email, and city. Other than age, rest of them is the string and age is the integer. This is a very simple JSON file. So what if we have the little complex? When the JSON file have a multi-node. So here is the example for a multi-node JSON. So you can see the open and close braces. Within that, we have a ID, name, email, address, and then the person is having the two orders. Okay, within the order, I have the order underscore ID 1, 2. So this is a little complex than the previous example. So let's look at the schema for this. If you look at the schema from the root level, ID, name, email, address. Within the address, you can see the street, city, state, and country. So address is the structure. The rest all is a very straightforward data types, integer, strings. And similarly, order is an array that contains the structure. Each order ID 1, each structure would contain the order details. Order ID 1, product and the quantity. Similarly, order ID 2, product and quantity. So this is the complex structure. So always when we talk about the JSON with the semi-structured data with the multi-node JSON, it would be combination of both array and struct. So why do we need to flatten this data? So here is a syntax for spark.read JSON and provide the JSON path. We usually use a HDFS path if it's a cluster mode. As I showed in the example, the array and structures are the complex data types. It needs more coding effort to read. For example, if it's an array, we need to explode it, read the schema, explode it, and then pass the data within the array. Similarly, structure, we have to go with the dot notation, object dot each field. So what if the source data structure, the schema is changed? What if we have a multiple JSON files to be handled? So to avoid more coding effort, so we need to flatten the data so that our coding effort would be less and all complex data from array and structure becomes very flattened and easy to use it. So here is an example. So we have seen this data, the JSON and schema, and how it looks after the flatten. If you see, we have this the whole schema, and you can see the schema itself: ID, name, email, address underscore street, address underscore city, address underscore state. So if you look at the address, is the structure. So what the final output would look like: address underscore street, address underscore city, address underscore state, and similarly address underscore country. Let's see how the final output of this order look like. So you can see order underscore ID, and the similarly for the product and the quantity. So here I have one particular ID which is having two orders, 1 and 2. Once we flatten it, we get the two records instead of one record. So that would have addition to ID, name, email address. You can see the address which is remained same for both the records, and you can see the order ID which is bearing it. So how are we going to achieve it? So for this purpose, I created a generic code to handle this. So the code is available in GitHub. I made it as a very generic function. So if you look at this JSON parser, which would read the data frame. So the data frame would contain the XML or JSON. So I'll just quickly walk through this. So what I did was I have this run flag, set it true. So I set the while loop. As soon as it gets in, it becomes false. So why do we need this while loop? Is in order to loop through the whole schema of the data frame. So the idea is very simple. It's going to read the schema. For each element, it's going to see whether it is an array or structure. And then it's going to, if it is an array, it's going to do the explode. If it is structure, it's going to concat the parent and the child with the underscore. And finally, it will loop through the whole JSON and then return the flattened data frame. So the flattened data frame would look like this. If you have a JSON with 3 IDs, 3 orders or 5 orders, based on that it would be flattened. If it is a 5 orders, you'll get a 5 records, and it's we have to write a query to read the latest, or based on the business logic we need to handle it. It's very straightforward. You can refer to this particular code, JSON parser.scala. So all you need to do is you have to take this definition of this function and incorporate it in your code. So I added the nodes in the README file. Thank you so much for watching this. If you have any questions, please comment below. I'll reply as soon as possible. Thank you.